Welcome back, fellow NASA HUNCH educators and students. My name is Miss Brittany Coker, and I'm going to be walking you through investigation station number 2 for our Lunar Scooter Wheel project. This is the mini tire test. This is where we're going to be talking about that regolith of the moon, which is the surface, and we're going to be talking about the different tread patterns and what those treads do. I noticed when I talked to my students about tread on a tire, a lot of them didn't know what the tread was for. So we discussed that a tread helps the tire move through different types of soils, different mediums that the tire may face, whether it be mud, asphalt, grass, rocks, dirt, water, ice, snow. There are different tread patterns for all kinds of different mediums and soils. So we want to talk about which one is going to be the best for the moon. So what do we know about the moon's surface? If you did the soil investigation lab, you looked at different soils here on Earth, and you discussed weathering, erosion, and deposition, and how those processes formed our Earth and smoothed our soils out, where that didn't happen on the moon. The moon does have a very light atmosphere, and it has 1/6 of our gravity. So things that hit the moon don't just bounce off and fly away. They do actually go back down to the surface after a while. The dust will settle. But think about those craters on the moon and what the moon looks like, okay? So the moon has been hit for many, many years by asteroids, meteors, and rocks and stuff floating around in space. And some of those have been large, which have created those very large craters, and some are small. But every time one of those hits and it breaks that rocky, hard rock underneath that soil and that lightweight dust on top, that rock is just being broken, and it's sharp and it's pointed, and nothing's moving around. There's no wind, there's no water, there's none of that on the moon to move that around and smooth that out. So we don't want any of that regolith, that sharp stuff, to get stuck in our tire. We don't want that sharp stuff to be kicked up into our astronaut suits. We want to keep our astronauts very safe with this. Okay, so we got to test out different materials to see, to simulate what that surface of the moon would be like. So I have a pan of flour. I have a pan of sand. And I also have some Play-Doh. And we're going to be using these to simulate the surface of the moon, okay? Because it's like flour and sand kind of mixed together with those sharp pieces on top of like a hard rocky surface. That's what the moon is very like. So what we are going to be paying attention to today, which I have some 3D printed tires. You can go out and buy Tonka trucks or any RC cars, anything that has a tire that you can test. Hopefully we might have a way to get you guys some 3D printed tires. If you have a 3D printer, you can print these. These were super simple. I Googled RC car tires on thingiverse.com and downloaded them and printed them out. So I have several of these that I gave my students, and I gave each group, I had groups of about six students, 5 to 6 students in each group. So I tried to give each one of them a tire to test. And we tested it in 3 different mediums. First, we tested it in Play-Doh. Play-Doh was our very first thing that I gave them, and I gave them all one. And we want to test the tire in Play-Doh first because flour and sand is going to get the Play-Doh dirty. So you want to flatten out your Play-Doh on your table, get your group to flatten it out, and you're going to need a measuring tool for this, so a ruler, to give the students a ruler and go back over measurements and how to read a ruler correctly, and that there are 16 marks between 1 and 2, and you want to go to the exact mark and to see how deep this tire tread will be. Okay, so you're going to get your tire, you're going to get your ruler, you got my Play-Doh laid out, and we're going to use a pencil for our axle. And I took a moment to go into what a wheel and axle is and why an axle is so important when you have a wheel. So there is a video that shows a little bit more about wheels and axles as well. So we're going to stick our axle through the center of our tire, and we're just going to roll it. We're not pushing real hard. We're just going to roll it. I'm going to put it down, and I'm going to roll it forward. Okay, yeah. Look at this. Look at that tread mark there. That's what we want to see. And we want to take our ruler and we want to get it down in that tread mark and count how deep that is. And that is 3/16 of an inch in the Play-Doh. And then I would have the students record that information in the slide. and then they flatten it back out because the next person's going to test in the Play-Doh. And they work together and they talk about it together as they go. So that was 3/16 of an inch in the Play-Doh. Now, we're going to do the same thing, but we're going to start with our sand. We're going to smooth it out nice and smooth over here. All right, and we're going to do the same thing. We're going to stick our axle through, and we are just going to roll it. And I asked my students, I said, there's several things I want you to look at while you're rolling this. Does it pick sand up? Okay, as you see, no sand's falling off of it, so it did not pick any sand up. No sand got stuck on the tire. But did it kick it up behind it as it's rolling? If you've ever rode your bicycle or scooter or something through the mud or four-wheeler in the mud or in the rain, when it's raining and the water got kicked up on your back, same thing. We want to watch out for that because we don't want that to happen. So let them pay attention to that. And they should have a very good mark in their sand there. I know that's hard to see, but I do have a really good mark in my sand. And we're going to do the same thing. We're going to get a ruler. I'm going to stick it in the deepest mark. And it only left 2/16 of an inch of an impression in the sand. And then my students would smooth that back out to do the next one. And we're going to do the same thing with our flour here. And this is where it gets messy. If you've ever played with flour, flour is very fine, very thin, very dusty-like. So that's why I said it's a very good representation, as you see it floating around there, of what the moon would be. It's kind of like a mixture of all of these together, like rock underneath, sand, and flour together. So same thing, put our axle through and roll it really deep. Oh, look at that. Did you see all that fall off of there? Look how much it's picking up. Ooh, this tire is not a good representation of what we need on the moon. Look at all that. It picked up a lot. It did not leave a very good impression because it picked a lot of that flour up in the tire. So we will measure this. We will see the deepest part. Ooh, see, it went 3/16 of an inch into the flour. It only went 2/16 of an inch into the sand, okay? So it picked up flour and it kicked it up. As it was picking it up, it was kicking it up. So this one, which was a sand paddle, this is actually a design for sand, did really well in the sand. It didn't kick any up, or it didn't pick it up. It just kind of moved through it. But it didn't move very well through the flour. And those are also questions that are in this slide. It asked them, how well did the tire turn? Was it hard to push through? Did it pick up a bunch? Did it leave a good impression? All of those are questions that you're going to need to answer. And then you're going to test different tires. Same thing. Run them through the Play-Doh. Get you some good marks in your Play-Doh. Get you some good marks in your sand. Ooh, see, that one did really good in the sand. It moved very easy. I've got a very good tread pattern in the sand there. And then we're going to do the same thing in the flour as well. Let's see if this one picks up some flour. Turn it the right way and roll it. Okay, notice this one did pick up a little bit of flour, but nowhere near like the other one did. I have a very good mark and a very good impression here. And I'm going to go and measure all of those about 2/16 of an inch, 1/16 of an inch, and 2/16 of an inch. So do all of those. Test as many tires as you can and record that data. This data is going to help us as we are designing these tread marks that are going to go on our tire in the end. So test as many tires as you can. Have fun with this. Let your students discuss, have whole group discussions about what they noticed about each material and what they noticed about the tire treads, and ask them, what type of material do you think this tire was designed to go through before they test it, and see if they can get it right, and go Google and figure out all of that as well. So just test out your different tires and your different mediums, write down your answers, and we're going to use all of these tests when we design our tread pattern. Thanks, guys. I hope you had fun with this station. Hope you got a little messy and enjoyed it. Have fun, guys. I'll see you at the next investigation station. Bye.